384,000 kilometers from home, floating in the crushing silence of the void. No air, no sound, just a golden machine drifting through the absolute dark. This is Chang'e 5. It has been traveling for 112 hours straight. Its target? A forbidden volcanic plain known as the Oceanus Procellarum, the ocean of storms. A place where no human footprint has ever been set. But this machine didn't come here to plant a flag. It didn't come for glory. It came to dig. And what lies buried beneath that gray dust isn't just rock. It is a discovery so powerful, it is about to rewrite the timeline of human history. This wasn't a mission. This was the beginning of a new era.
3, 2, 1, 0. All engine running.
Between 1969 and 1972, Apollo landed 6 times on the moon. All 6 missions landed in the same region, the ancient equatorial highlands. Across all missions, astronauts spent a combined 80 hours on the lunar surface, bringing back a total of 382 kilograms of rock samples. When scientists analyzed these rocks back on Earth, they used radiometric dating, a technique that measures the decay of radioactive elements trapped inside minerals. The results shocked them. The rocks were 3.8 billion years old, ancient, primordial. The moon's crust had formed and cooled billions of years before humans even existed. The rocks confirmed that the moon was once geologically active. After that, for 44 years, nobody brought anything from moon back to Earth. In late 2020, China's robotic spacecraft, Chang'e 5, touched down in a completely different region of the moon, known as the Oceanus Procellarum, a fresh, untouched region. The mission was simple: land, drill, grab 2 kilograms of soil, and get back to Earth. But unlike Apollo's shallow hand scooping, Chang'e 5 used a mechanical drill that bored into the lunar surface, finding sealed layers never exposed to the vacuum. The lander only had 48 hours before the freezing lunar night would kill its batteries, so it worked like a machine possessed. It collected 1,731 grams of fresh samples and sent them back to Earth. It was the first time in 44 years that humanity brought moon rocks home. But when Chinese scientists at the Beijing Research Institute cracked open those canisters, they didn't just see dust. They saw the future of energy. They began analyzing the samples grain by grain. And deep within that black basaltic powder, they found a tiny columnar crystal. It was thinner than a human hair. They named it chang'e Y. But it wasn't the mineral itself. It was what was trapped inside it, helium-3. For billions of years, our sun has been blasting the solar system with solar wind, a stream of high-energy particles. One of these particles is a rare isotope called helium-3. On Earth, we don't have it. Our planet's magnetic field and thick atmosphere block the solar wind, protecting us from radiation, but also bouncing away this precious resource. But the moon has no atmosphere. It has no magnetic field. It has been sitting there naked, soaking up helium-3 like a giant sponge for 4 billion years. Because helium-3 is the holy grail of nuclear fusion. Current nuclear power plants use fission, splitting atoms. It's messy, it creates radioactive waste that lasts for thousands of years, and it's dangerous. But fusion is how the sun works. It's smashing atoms together. If you fuse helium-3 with deuterium, you get a reaction that produces massive amounts of energy, with 0 radioactive waste and 0 greenhouse gases. It is the perfect energy. The math is terrifyingly good. It is estimated that just 100 tons of helium-3 could power the entire world for a year. The moon is estimated to hold over 1 million tons. That is enough energy to power human civilization for 10,000 years. China didn't just find the fuel, they figured out the extraction method. They now have the blueprint for lunar mining. At current valuations, helium-3 is worth roughly $3 billion per ton. But really, it's priceless. The country that controls the supply of helium-3 controls the energy grid of the 22nd century. But energy is only half the equation. To mine the moon, you have to live on the moon. And to live, you need water. For decades, humanity thought that the moon was a dry planet. But then China made another discovery, not with Chang'e 5, with an earlier mission. January 3, 2019, the Chang'e 4 mission successfully landed on the far side of the moon, the dark side, a place eternally hidden from Earth's view. It touched down in the von Karman crater located inside the massive South Pole Aitken Basin. This is the oldest, deepest, and largest impact crater on the entire moon. The lander deployed a small rover called Yutu-2. Yutu-2 was built to roam the far side, to explore the deep unknown. As Yutu-2 rolled across the von Karman crater, it started seeing something strange. Translucent spherical globules. They looked like glass marbles, standing out against the dusty gray background. These were impact glass, and when scientists analyzed similar glass beads, brought back later by Chang'e 5, they confirmed what Yutu-2 had hinted at. Inside these glass spheres was trapped water, billions of tons of it, locked away inside tiny glass cages, waiting to be released. The solar wind deposits hydrogen on the lunar dust. When a meteorite hits, the flash heating converts that hydrogen and the oxygen in the rock into H2O and instantly traps it inside the cooling glass bead, a time capsule of water. These beads are everywhere. The discovery of Chang'e Y and the water-bearing glass beads was so significant that they launched an even more ambitious mission, Chang'e 6. By 2030, China plans to land its first astronauts on the moon. And by 2035, they aim to complete the first phase of the International Lunar Research Station, a permanent robotic outpost at the South Pole, powered by nuclear reactors, with pressurized rovers, mining equipment, and communication networks connecting the moon to Earth. They aren't just doing science anymore. They are doing industrial prospecting, and we are witnessing the birth of the lunar economy,